Alrighty, here we go. Another test review. Getting ready for test review. Test review unit 12. We want to make sure you're ready for, or at least me. I want to make sure you're ready for the next test, and hopefully we'll be paying attention and going through every problem. Now again, fast forward through stuff you feel like you already got. Slow down or pause and rewind on the things that you feel like you need extra emphasis on. Anyways, so let's look at this. Let's start with number one. So for number one, we've got this radical equation. So how do I get rid of a radical? How do I get rid of a square root? Okay, first off, make sure the square root's by itself. In other words, there is nothing outside of this parentheses except on the right side, which says equals 8. So it's by itself. That means I can get rid of a square root with a square. So I got to square both sides. Again, make sure that you're always doing the same thing on both sides. You get 5x minus 4 equals 64. Then from there, all you got to do is 2 steps, add 4, and then divide by 5. So, we've got our add, subtract step, and then divide. And you get 68 over 5. That doesn't simplify, so that's all it is. Now, if you look at number 2, this one says cube root. But here's the other kicker. This right here is not isolated. The radical is not by itself because I've got this minus 5 on the same side. So I've got to add 5 to both sides. And then I have the cube root of 4x plus 7. Now the radical is isolated. So now how do I get rid of a cube root? Well, cube it. So notice how the 3, the number that's on the radical, the exponent will match that. So I'm going to put a 3 there also. And then I get 8 to the third power is 512. And so again, subtract 7 and divide by 4. So you see the steps seem to repeat quite often. We're going to get a lot of these where you subtract and then divide. Or add, then divide. So let's look at number 3. Here it's a little bit more involved. So here I've got to get rid of the plus 8 first. So I'm going to subtract 8. And then I'm going to divide by 3. Because that 3 is in front. And then from there I can get rid of the square root, which would be to square it. And then again, subtract 2, and I would have my final answer. If there was a number in front of the x, then I would divide 2, but I don't have to. So there we go. So there, my answer here is 47. Fairly simple, right? This is easy, sir. I can do this. Well, I'm glad you believe that, because I believe in that too. All right. Now here, this is our exponential functions. And again, the idea is that we need like the same base. So if they're the same base, I can cross out the bases, which are the 7s. And then that would leave me with 5x minus 7 equals 3x plus 11. In this type of problem, I always like to say variables to the left, numbers to the right. Basically, they change their signs. So I'm saying 5 minus 3 is 2, 11 plus 7 is 18, and then I can divide. And I get my answer. But what if they're not in the same base? Oh no. Well, this is where that exponent table comes in handy. So if you had your exponent table, you would be able to tell that 49 is 7 squared. And notice how I put the rest of the exponent in parentheses. And then 24 over 1 is 7 to the 4th power. And again, putting the rest of the exponent in parentheses. So now I can drop the 7s and distribute to get 6x minus 8 equals 4x plus 32. And then again, variables to the left, numbers to the right. And then after that, you would divide. Fairly simple, right? I'm impressed that I got 2 answers that came out even in a row. On the test, I don't know if that'll happen. Because honestly, guys, I just want to kind of see what happens. Alright, so let's look at number 6. Okay, on number 6, again, this is another one where the exponent table would be very beneficial. If you had that exponent table, you could easily recognize, and here's me building up the 4s, that this is in the powers of 4s. And that 1 over 256 is going to be 4 to the negative 4 power. And 4096 should be 4 to the 6th power. So I would write there 4 to the 6th power. I'm getting there. Okay, 4 to the negative 4 power. And notice how I put times the 3x minus 4. And then 4 to the 6th power times the 4x plus 7. And then again, cross out the 4s, cross out the bases, distribute. Negative 4 times 3 is negative 12x. Negative 4 times 4 is positive 16. 6 times 4 is 24. 6 times 7 is 42. And then again, variables to the left, numbers to the right, and then I got to divide. And yes, you will get a fraction answer on that one, and that's okay. If you type it in the calculator, it would simplify the fraction for you to negative 13 over 18. And that's it. So there's that, problem number 6. Again, nothing too complicated. Okay, so starting with problem number 7, I want you to find the exponential function. So how do you find the exponential function? Well, the way you find the exponential function is to at first identify a, x, and y. Put them into the formula y equals a times b to the x power, and you're going to find your b. So notice here how I'm putting 54 is equal to 2 times b to the third power. Then, same 2 steps every time. Divide, and then take the root, the radical. So there, the exponent has to match the number that, or the number on the radical, the index, will match the exponent that you had with the b. So I'm going to take the third root of 27. Some of y'all were only doing square roots. It's going to be third root. And the way to get that, again, by the way, is control and the caret key. That would give you, like that, where you could put a number here and here. Anyways, b is equal to 3. So then to rewrite that as an equation, a is 2, b is 3, raised to the x power. Number 8, same thing. Just make sure you're careful with dividing by the 1/3. So I'm going to let it kind of run through, but make sure when you divide by 1/3 on the calculator, make note that you need to make sure you put it in parentheses. That will make sure it reads it correctly. So this one I get, and I'm going to take the 5th root. So again, make note that it has to be the 5th root. 1/3 times 7 to the x. And then on number 9, that one I think you're going to get like again, make sure you're dividing by 4/5, but I believe you're going to get like 0.667, which you should recognize is to be 2/3. If you don't have, and so I mean, if you put the 0.6666667, that's fine. I mean, but I would hope that you would recognize that that's 2/3. But I would accept 4/5 times 0.6666667 to the x power, or what I would have preferred is 4/5 times 2/3 x. But we'll see about that one, okay? Because they are going to have to try to limit the number of problems that can be on this test. Anyways, so that's it for number 9. Let's look at number 10. Okay, so number 10 and number 12 have this recording, or like have this, like they're just basically trying to rewrite them in the same, in different formats. So you can see the answer for number 10, which is fairly easy. Here's number 11. I'm saying that 7 to the negative 3 is equal to 1 over 343, and I want to rewrite that in log form. Well, again, log base 7, remember this is the base, the exponent is what you're equal to, and then the 1 over 343 would be next to the base. And there's your answer. Or on number 13, where I need to write log base 7, 1 over 49 equals negative 2, I would rewrite that as 7 to the negative 2 power equals 1 over 49. So this is exponential form. So those should be fairly easy. I'm pretty sure y'all won't have any problems with those. Also on 14, where you have to, like 14 and 15, where you have to type them into the calculator, again, make sure you know how to type them into the calculator. Press Control 10 to the x power. And then like something like here, where I'm saying log base 3 of 1 over 729, and it depends on what the calculator gives you. Like I would read number 14 as 3/2, but that's what I know. And the calculator gave it to me as 1.5. So go with what the calculator gives you. In this case, that one should give you a negative, let's see here, 81, 243, 729. I believe that is negative 6. I double checked my work, and yes, it was negative 6. So, hey, Happy Joy, I did it right. Isn't that special? So I made sure that I'm not giving you all the wrong answers. So yes, I did it right. Happy Joy. Okay, so now let's look at problems 16, 17, 18, stuff like that. Oh, I already gave you the answer there. Okay, so on 16 and 17, notice that it's logs on both sides. If they're logs on both sides and the log bases are the same, I can eliminate the logs and say 4x minus 5 equals x plus 16. And again, this is one of those problems, variables to the left, numbers to the right, And then after that, once you got through two answers, you can divide. So in this case, I get x is equal to 7. Not bad. Number 17, same thing. It's going to be log base 2, and I'm going to be able to cancel out the log base 2. And then after that, I can go ahead and say 3x minus 4 equals 7x minus 35. Number or variables to the left, numbers to the right. And once I do that, I should get negative 4x is equal to negative 31. And then all I got to do is divide by negative 4. And that would give me that answer. And that's it for that one. Okay, so let's look at 18. Are there any questions? Oh, wait, you can't ask questions when I'm doing it like this. Ha ha. Just kidding. Alright, so let's see here. The log base 5, 7x plus 2 equals 4. Well, okay, how do I get rid of the log 5? I don't know. How do you get rid of the log 5? Well, you make it into an exponent of that base. So log 5 raised to the log 5 power, that makes sense, those cancel each other out, leaving you the 7x plus 2. But basically that means I'm also saying that the 4 is now the exponent for 5, and so I'm saying 5 to the 4th power, which means 5 times 5 times 5 times 5, which would give me 625. Again, to do that, just press the caret key, like you'd go 5, press the caret key, type in the 4, and then press enter, and you get 625. And then from there, it's a simple two-step equation, subtract and then divide. And if it comes out even, it comes out even. If it doesn't come out even, it doesn't come out even. Although it would have been nice if my second period had told me that this came out even, and they were like, no, that's it, like that. Nah. Shame on y'all. Anyways, and thank you for the person in 5th period that pointed that out to me. Anyways, let's look at the next one, number 19. Same thing. Okay, so in this case, notice that you will get a fraction. If you type it into the calculator, recognize your next steps. Okay, so like the next step is to add 5 and then divide by 2. Then go ahead and type that into the calculator. Like you have 1 over 16 on the calculator, and then you press plus 5, enter, then divide by 2, enter, and you will end up with the correct answer, which in this case was a funky fraction of 1081 over 432. And there you go. That's it for that one. How many of those I'll have, I don't know. Now on 20 and 21, you got to make sure the logs are isolated. So notice here, like this log has this plus 8. I've got to get rid of that first. So I'm going to subtract 8. And then I would get log base 7 of that is 3. And then I get rid of the 7s. And now it becomes just like what you did on the previous problem. And then you go from there. Like you would say raise it to this 7 to the 3rd power. Then you could add 3 and then divide by 2. And it's that simple. So you kind of just keep working like that. Number 21, same thing, but notice that the number is in front of the log. That means it's multiplying. So how do I get rid of multiply? I divide. Then I can take a base. And again, if there is no number at the base, then presume that's a base 10. And then you could say, okay, I'm going to raise this to the 10th power, or 10 to the 4 power, and then go from there, subtract 1, and then divide by 4, and you would have your answer for that. Okay, so now let's look at number 22, which I said I would not cover in class. I would only cover on the review video, since it will be counted as a bonus. Okay, so you can see here that this is one with logs on both sides, and the logs are the same base. So I can cross those out and say x squared equals x plus 12. So now this is like a quadratic formula, or this is a quadratic equation. So this is a problem that you could easily have done in a number of different ways, but you know, it's right there. Now with quadratics, everything needs to be on the side of the quadratic, and I want that quadratic to be positive. So here I would get x squared, the x would move over and become negative x, or negative 1x, and the 12 would move over and become negative 12. Now you've got two choices. You can graph this and see where they cross the x-axis, or you can factor it. Either one, wherever they cross the x-axis, that would be your answer. Here, I would have done, if I do the factoring, I get x minus x plus. Factors of negative 12 that subtract to give me 1 are 4 and 3. 4 times 3 is 12, negative 4 plus 3 is negative 1. And then again, the zeros here would be at negative 3, I'm sorry, got positive 4 and -3. Just remember, it's always the opposite of those in the parentheses. If you looked at the graph, it would cross at -3. That's crossing at -3 and at 4. And so you would tell me again those same answers there too. And that's it. That's all those are. So it's not something that should be very difficult. And that's pretty much it. Somebody said I shouldn't put a magic word today, but you know what? I like it when y'all listen to my videos. So let's see. I'll go ahead and say that the magic word for today is... that's a good question. What could my magic word be for today? Oh, I have no clue. I'm just going to say... I say today's magic word is champion. That'll work. Champion is the magic word. Make sure you have that on the test. Don't share it with others. Make sure they listen to the video. Anyways, that's it for today, guys. Thank you so much for your time. Y'all take care, and I hope y'all do well on the test.